Cell phone battery. A cell phone or computer battery has three ratings marked on it. A charge capacity listed in milliamps hours, an energy capacity in watts hours, and a potential rating in volts. What are these three values for your cell phone? Convert the charge capacity into coulombs, convert the energy capacity into joules, and multiply the charge rating Q by the potential rating V and verify that this is equivalent to the energy capacity U. And if the charge Q were stored on a parallel plate capacitor with air as the dielectric at the potential V, what would be the corresponding capacitance? And if the energy in the battery were used to heat 1 liters of water, estimate the corresponding change in the water temperature. The specific heat of water is 4190 joules per kilogram Kelvin. Okay, so for this example, let's pick an iPhone 14 Pro Max, which is MagSafe. The charge capacity is rated as 4,323 milliamps hours. This you can easily find on the web. And 1 milliamp is 10 to minus 3 amps. The energy capacity is listed as 16.7 watt hours, and 1 hour is 3,600 seconds. The potential rating is 3.85 volts, which is the lithium ion battery. So these are the values listed for an iPhone 14 Pro Max, which is MagSafe. Now in part B, we were asked to calculate the charge capacity in coulombs. The charge capacity Q is 4,323 milliamps hours. That is 10 to minus 3 amps, and 1 hour is 3,600 seconds. So this gives us a charge rating of 1.60 times 10 to 4 coulombs. That's the charge rating of this cell phone. Part C asks us to convert the energy capacity into joules. The energy capacity was listed in part A as 16.7 watt hours. So that is 3,600 seconds. That's 1 hour. So this gives us an energy in joules, 60.1 kilojoules of energy. In part D, we're asked to calculate this energy by multiplying the charge rating with the potential rating. So let's do that. U is equal to QV. Q times V is 4,323, 10 to minus 3, 3,600. That's the charge in coulombs multiplied by the voltage rating, 3.85. This gives us an energy rating of 60.0 kilojoules, which is equivalent, because we have the uncertainty in the last digit, equivalent to the energy capacity that is given in part A. Okay, now in part E, if the charge were stored on a parallel plate capacitor with air as the dielectric at the potential V, what would be the corresponding capacitance? The charge stored, Q, is the potential difference applied to the plates of the capacitor multiplied by the capacitance. So we can see that the capacitance will be Q divided by V. So we have 4,323 milliamps hours, 10 to minus 3, 3,600 to convert to coulombs, divided by 3.85 volts being applied to this parallel plate capacitor. This would correspond to a capacitance of 4.03 times 10 to 3 farads, which is a humongous capacitance. It's very, very large. Part F. If this energy in the battery is used to heat 1 liter of water, estimate the corresponding change in water temperature. Okay, so this energy, U, is applied to 1 liter of water. So there is no phase change, so that the amount of heat we transfer is mc delta T, which means delta T, change in temperature, is the energy we supply divided by the heat capacity, which is the mass multiplied by the specific heat. Okay, so we have 60.1 kilojoules, 10 to 3 joules, being applied to 1 kilogram of water, specific heat 4190. This gives us a change in temperature of 14.3 degrees Celsius. So it would increase the temperature by 14.3 degrees Celsius. Now here, mass of the water is density of the water multiplied by its volume. So the density of water is 1000 kilograms per meter cube, and the volume is 1 liter, and 10 to minus 3 meter cube is 1 liter. So this is basically 1 kilogram. So note that 1 meter cube is 1000 liters. So that's how I convert the units. Okay, so in this example, we were asked to find the ratings for the cell phone battery, and these are given in part A, and then convert those ratings into coulombs and joules. That's what we did in part B. Q is equal to the rating given in milliamps hours multiplied by 10 to minus 3, 3,600 seconds to convert to coulombs. And the rating given in watts hours, 1 hour is 3,600 seconds. So that gives us in joules. If I multiply the charge rating and the voltage rating, potential rating, this should give me U. That's what I have verified in part D. Q times V is U. And if I store this much charge on a parallel plate capacitor, the capacitance would be humongous, 4.04, 10 to 3 farads. And if I use this energy, this much energy to heat water, 1 liter water, I would see that its increase in temperature is U divided by mc, the energy supply divided by heat capacity, or mass times the specific heat, that is 14.3 degrees Celsius. Here I was careful about the conversion of units to find that 1 liter of water is actually 1 kilogram in mass.